In these next few problems, we're going to look at strictly graphs and determine if certain graphs are or are not functions and why. We're going to look at the vertex of the graph, and we're going to determine the domain and the range in an interval and a set notation. So to begin, we've got a graph, and we want to know, is it a function or is it not a function? And we know that these are going to go on forever. So when we apply the vertical line test, it only hits in one spot. So yes, it is a function. Now, the vertex is 0, -1, so that's going to be an important point. So now we want to discuss the domain. So the domain in interval notation, we're looking for this graph on the x-axis, so we're looking left to right for the x-axis, and the domain values will run from -infinity to +infinity. And the range will not run from +infinity to -infinity, because it stops and is limited when y is -1. So we're going to include -1 with the bracket and go to +infinity. That would be your interval notation. So when we look at set notation, the domain, since it's all from -infinity to +infinity, our domain will be the set of all values x such that x is an element of all real numbers. So remember, this line here just is a such that. This means element or a part, and this means all real numbers. And the range, since we went from -1 to +infinity, the range will involve y values. So the y, all values y such that y is greater than or equal to -1 would be one way to write that. Or you could say all values of y such that -1 is less than or equal to y. Either one of these would work for your range, and there would be your domain. Second graph is a circle, and when you test vertical line test, you see that it does hit in two spots. So you would say this is not a function because it fails the line test. So what would be the domain? The domain, this is -1, and this is 5, 0. Those ordered pairs were given to us here. So the domain would be from -1 to 5, -1 to 5, and the y values would be from -3 to +3. And we're going to include both of them, and that would be our interval notation. Set notation would be, for domain, would be all values of x such that x is smaller than or equal to 5 and -1 is smaller than or equal to x. The range would be the same way. Set of all values y such that y is less than or equal to 3 and -3 is less than or equal to y. That would be your range. Check the line test here, and we see that it fails. So this is not a function. because it fails the line test. So this is not a function. So the domain, looking at all the possible x values, actually stops right here. So this ordered pair is important. That 15, the maximum distance on the x-axis is 15. So the domain would be from negative infinity to positive 15 and include it. And the range is the y value. So we're looking up and down on this graph, and this graph's going to increase and increase and increase off the charts, and this will decrease and decrease and decrease off the charts. So what we have is from negative infinity to positive infinity is our range, and this is interval notation. And then our set notation would be from set of all values x such that x is less than or equal to 15. Or you could have written the set of all values x such that uh, 15 is greater than or equal to all the x values. The range would be the set of all values y such that y is an element of all the real numbers. What we have is a square root function, and it passes the vertical line test, so we will say yes, this is a function because it passes, oops, passes the line test. So our domain in interval notation, since the vertex is at 0, 0, we're actually on all the x values, the smallest x value is at 0, and that's going to run to positive infinity, and the range is going to do the same thing because the vertex was 0, 0. So it's going to go from 0 to positive infinity. And that's for the interval notation. The set notation would be the set of all values x such that x is greater than or equal to 0. And the range would be the set of all y values such that y is greater than or equal to 0. This graph, when you check, does fail the line test. So this is not a function. Due to it fails the line test. So the domain in interval notation, this is important, the vertex. So the domain would be all values as far left as -1, and we're going to include it, and it'll run to positive infinity. And our range is everything increasing in this direction, so we are looking at an all real numbers for range on the interval notation. So our set notation for the domain would be the set of all values x such that x is greater than or equal to 1, and that should be a positive 1, my mistake. There should be a positive 1 there. And the range is I'm looking at the y value, And notice the y value of the vertex is 0, so this would be the set of all values y such that y is greater than, excuse me, I got mixed up there. Set of all values y such that y, because I'm looking at my range here, y is an element of all the real numbers. In this particular graph, we're looking at, it does pass the line test. So this is a function. Because it passes the vertical line test. Domain and interval notation. The domain would be all the x values. So you look at this graph and all the x values this way. The more x values I go this way, there's going to have y values way down here. The more I move this way, the more y values will be down here. So you're looking at a negative infinity to positive, so all reals. And the range, careful, it's going to be 216. So up here, it's a maximum value of 16 on the y value. So what we're going to have for range and interval notation is from negative infinity, because remember it continues to go down. So from negative infinity to positive 16, and that is inclusive. So I need a bracket. Set notation. Domain. Well, if the domain in the interval notation was negative infinity to positive infinity, the set notation would be the set of all values x such that x is an element of all real numbers. And the range would be the set of all y values such that y is less than. Remember, the graph is opening down, so y, all the set of all y values such that y is less than or equal to 16. And one more with our graph, finding domain and range. It does pass the line test. This is a function. It's a linear model. So this is a function because it passes the line test. So what's the domain? Well, in interval notation, it would be a negative infinity to positive infinity. Range would be the same, negative infinity to positive infinity. Set notation would both represent these all reals. So we would have the set of all values x such that x is an element of all real numbers. And the range would be the set of all values y such that y is an element of all real numbers.